All right, so in this video, we're going to talk about functions and how to use functions. So a couple definitions here first. A function or functions is a relationship between two variables where for every independent variable, there is only one dependent variable, right? So an example I like to use, right? So say a function is a store. So two people go into the store, each person buys the same items, X, and when they go to check out, the price that they both pay must be the same. Why? Right? I can't charge someone more for the exact same items because it's just unfair. So that's how you kind of think of it. So the items in the store are your X or your independent variables, and what you purchase depends on the price. So that's why the dependent. It's depending on the item. So the output is the dependent because it depends on what's coming in. However, you can have the same Y for multiple X, right? There are many items X in the store that cost the same as Y, right? I can go in and there can be a $2 soda, there can be a $2 candy bar, and there can be a $2 notebook. So it's okay to have multiple items that cost the same. We just can't have one person buy a candy bar for $2 and then the next person we charge $2.50. You can't have the same item have two different prices. So that's a non-math example. I like to try to explain how it works. Another one I like to use is how functions work, right? So not getting into extreme biology here, but the human body, we have our lungs, right? And when we breathe, we need oxygen, right? To survive. And of course, I know we breathe in a lot of other things, but we need oxygen to survive. So oxygen comes into our lungs, right? And our lungs process the oxygen and we release out carbon dioxide, CO2, and among other things. Very simple biological problem. Sorry for my biology majors. It's probably more that function is more complex than that, but we're going to simplify it to kind of understand how functions work. So our independent part of our function is oxygen, and it comes in and our lungs process it, right? And they do something. And that's what functions do. They take what you put into the function, it does something with it, and then it gives out a result. And in our lungs case, it gives out CO2. So independent values come in, dependent values come out, right? The amount of carbon dioxide that comes out of our body depends on how much oxygen we breathe in. And then, so that's why it's independent. Independent was what comes in, dependent is what comes out. We also say domain is what comes in, and range is what comes out. So there is our kind of our things here. So to do a kind of a simple math equation, say I have the function, and typically I called it y and x, so I'll do a simple one with y and x so we can see it, and then I'll write in function notation. So say y equals 3x plus 2. And we can see right now, if you remember, this is the equation of a line. So if x is 0, right, then y equals 3, change my color here, times 0, that's why I put it in for the x value, plus 2, 3 times 0 is 0, plus 2 is 2, so y equals 2. So x of 0 went in, right? So this is my independent value. And based on that, I don't know what lines. Based on that, A2 came out, and that is why it is our dependent value. It is dependent on what goes in. Now, what makes this a little trickier is we're going domain, right? Like I said, that is our independent variable. basically what is coming in. And the definition is all possible values for the variable. And typically, we call this x. It doesn't always have to be, but typically that's what most people spell variable, right? V-A-I, variable, x, right? And that's what makes domain hard. Our previous problem, I only picked one x value, but remember, a line goes on forever, right? A line goes on forever, so that means our domain of a line our domain of our line is all real numbers. Probably should just type that out, been a lot easier and quicker and neater. All real numbers, right? Because a line goes left and right forever. So there is infinite x values, which means I can also write it as negative infinity is less than x is less than positive infinity. Those are horrible infinity signs, right? Because that also says all real numbers. That's algebraic notation. Or I can write it in interval notation, parentheses, negative infinity, comma, positive infinity, right? These are all different ways I can write all real numbers. And I can be extremely lazy, and this double line R is the symbol for all real numbers. But domain for a line only, this is for a line only, is all real numbers because it goes left and right forever. Now, range is our dependent variable because it depends on what you put in for into the function. And this is all possible values for the variable. And like I said, typically we call this y, not always, but that's where we go with it a lot. And again, if we stick to our line, our range is also all real numbers. And I'm not going to write everything again I wrote up top, but you can reapply that. And the reason is it goes left and right forever. That's why we have our slope, rise over run, because a line rises and runs forever. So for lines, our domain and range are all real numbers. Now, that's kind of the quick basic overview of what functions are. So let's see a couple of different types of problems so we can kind of get an idea how functions are. And I am going to use the software from Hawks. So depending on what math class you're in, you may use Hawks or you may not. So let me go to share screen, new share. All right. And now we have our Hawks. So here's a problem where it says, consider the following graph, right? And we have a bunch of points. And so good review of graphing. It wants us to list the pairs of points. So A is in quadrant, let's see, 3. And it start here at the origin. I go over to -5, and then I come down to -6. So -5, -6. B, I start at the origin. I come over to 5 and looks down to -4. So B is 5, -4. C, start at the origin, come over, that's 5, 6, 7. And I come down to, it looks like -8. So 7 and -8. -8. And then D, I come at the origin, I come over 5, 6, 7, up 2. So that looks to be 7, 2. That's how we read off our graph. I always like to start at the origin because the origin is 0. Oh, must have gone too fast. No, not explain error. Back to practice. Let's check our numbers because I missed something here. D is 7, 2. C is 7, 5, 6. Oh. 5, 6, 7, 8. That's right. One of these is off here. Oh, that one. A is not -6, -7. Make sure you count your lines properly. I'll leave this in the video just to remind us we all make mistakes sometimes. All right. Now it wants our domain. Remember, domain was all possible x values in this case, right? So, good news if you have Hawks, you can click on previous answer. Let's see if I can shrink this down so I can see both screens at the same time. There we go. And it shows you the value. So my domain is all possible x. So my x for A was -5, comma. My x for B was 5, comma. And my x for C was 7. And also for D, so I only list it once. Range are my y values, so -7, comma. My B is -4. My C is -8. And you don't have to put them in order. You can if you want. Because remember, I'm just listing all the possible values. I just went in order of points. You can put them in order if you want. You can see it does not matter. So remember, there's my domain and range. Now, one thing it wants to know if there's a function, right? So for something to be a function, remember, it has to have, every x has to have one y, right? But there is also another thing called a vertical line test. And this is how you make sure that every x has only one y. So if I draw a vertical line, the line can only pass through the function exactly one time, right? Now, you can have multiple lines, but it can only pass through. So what that means here, so I draw a line here, and it only hit A. And I draw a line here, it only hit B. Then I draw a line again through these points. I'm not on the line perfectly, but that's all right. You get the idea. I hit both C and D. I've hit 2 values on the vertical line test. So therefore, this thing has failed the vertical line test. So this is not a function. So the answer is no. All right, and the reason it's no is, again, it hit more than 1 point. So let me get rid of my drawing so they won't be in the way of the next page. Remember, a vertical line test. The line can only pass through the function and hit it exactly 1 time. All right. So this one, it says, is this a function, right? Even it goes left and right forever, but if I draw my vertical lines again, I guess I could have left them up, annotate, draw some lines just so you can have a visual with this. I only hit the graph, not really straight up and down, but you're getting the idea. I'm only hitting the graph once every time I draw a line. So therefore, stop drawing lines here. Yes, this is a function. It only hit it once. Leave our lines up in case we have another one here. These. Oh, I got a different part. So let's see, annotate, clear. So now it wants me to determine the domain and range. So remember, domain is all my x. So this goes left and right forever. So all real numbers. Now range goes up and down. This thing doesn't go up and down at all. So it is, y is only at 5. So the only y value I can have is 5. So the answer is y equals 5. Y equals 5. Oh, here, pay attention to your sign. I explained there. I did it again. Back to practice. Be careful. You guys will do this a lot, and you can see I do too. I'm going too fast. I am below the x-axis, so it is a -5, not a +5. There we go. So here's another one. Is this a function? Right? So if I draw my vertical lines, it only hits it once, only hits it once, only hits it once. So yes, it is a function. And then again, it wants domain and range. So we have to be careful, right? It has arrows on it, so that means it goes forever. So it's going to keep going up, so it's going to keep going this way, and it's going to keep going this way. So again, my domain is all real. Now my y, it goes up forever, but it doesn't go down. It goes as low as a +5. Make sure I get this one right this time, a +5. So I will do interval notation this time. So that is a bracket. Oh, I gotta use the keypad for this one. So if you're using Hawks, it's keypad. If you're in Pearson, use that keypad. So a bracket means it equals, so it can be 5, and then it goes to infinity. So that gives a parentheses. There's our funky symbol for all real, if you want to use that instead. And again, Pearson, yours is a little bit different keypads, but same exact concept. Let's see, I'm looking for a specific problem here. Perfect. So when we have, this is a function. So remember earlier I just did y and x. It doesn't have to be. A lot of times our functions are written with, you know, the values inside the equation are our domain. And the values outside the equation are our range. Now, to make functions a little bit easier to deal with in real world applications, we don't use more than one letter, especially because we use a lot of functions in computer coding and engineering, and it's just easier to keep one variable. The variable is just the x, the range is the output, right? So notice it is called the function, the little f means function of x. And again, our x is our independent variable because that is the variable or the letter that is inside the equation. So when it writes f of -3, remember, this is a symbol. There's no math here. This is a symbol. This is the symbol function of -3. You do nothing with it. That is a symbol. What you do instead is you put -3 into the equation. So I have 4 times -3, because that's the value inside the parentheses, and it's cubed, plus 3 times a -3. So now do some math here, and we've been practicing this, so we should be okay, right? You can use a calculator. And so we got -3 cubed is -27. So -27 times 4, I'm using a calculator line, is -108. So I get -108 plus 3 times -3 is a -9. Two negatives, when you add them, stay negative. Remember my drawing so I can actually type in there. There we go, negative. And -108 plus 9, 108 plus 9 is 117, and it's keep the symbol of negative. There it goes. So there is some simpler problems for domain and range. Some ones that are a little bit harder. So let me get rid of my drawings here. We'll go back to our whiteboard. There we go. Jumping between screens here is a little challenging, but I like to use the other one because it gave us some nice graphing. The more challenging ones are when you don't have graphs. And you can graph if you want, but what we can have here is, say we have f of x, that's an ugly f, it's a cursive f, f of x equals the square root of 3 plus x, right? And then we can ask ourselves, what is the domain? And remember, domain is all possible x values. So what you got to ask yourself is, well, what kind of function is this? Well, it is a square root function. So is there a limit of what you can put into a square root? Remember, we're staying in the world of all real numbers. So we know what's under the square root has to remain positive. So an easy math way to do this is if I do 3 plus x, we know this has to be greater than or equal to 0. Because anything greater than 0 is positive, and you can take the square root of 0. The square root of 0 is 0, so that's why I have the equal sign. Now solve for x. Subtract 3 from both sides. X has to be greater than equal to -3. And there's my domain. As long as I put in anything greater than or equal to -3, the function will work. It will not break. So my range, right? So this is how I like to do range. Once you find domain, put the worst case scenario in. So the worst case scenario is -3. So my function of -3 equals the square root of 3 plus a -3, which equals the square root of 0, which equals 0. So I know if I put the worst case scenario in is 0, and I know I'm always going to get positive answers, so my range is f of x is greater than or equal to 0. All right, so sometimes we don't have a graph. Look at the thing, and we can easily graph this thing by putting values in, right? Create a little table, x, f of x, right? So I already did one, so we know -3 gives me a 0, right? Well, if I put in f of 6, if I put a 6 in, right, f of 6, I get 3 plus 6 is 9, and the square root of 9 is 3. So this is 3. All right, and if I put in, say, 15, right? 15 plus, no, sorry. Yeah, 15. 15 plus 3, no, not 15. We can do 15, but I get decimals. I'm not trying to get decimals. Well, let's not use 15. Let's do, I'm trying to think of my square roots here. 13, there we go. If I put in the 13, so my 3 plus 13 equals the square root of 16, and the square root of 16 is 4. There we go. All right, so now we can graph this thing. So draw my lines. And so we have our x, we have our f of x. So when x is -3, so 1, 2, 3, -3, I'm right there on the line. When x is 6, 1, 2, 3, 4, 5, 6, I have a f of x of 3. And when is 13, so somewhere way out here, 13, I am at 4. So my thing is, well, I cannot draw with a mouse. Kind of looks like that. It will be a little smoother if I use the computer, but it's not a line. It's supposed to. A square root function kind of looks something more like that. No, it's not drawn to scale, but that should be more of a curvature like that, and a curvature like that. So let's try to erase this bottom one without messing up my stuff. There we go. Still not very good drawn. If I was in the classroom, I promise it wouldn't be any better. But now I can have a somewhat of a drawing here. I can do the vertical line test, and you can see I only hit the graph once, no matter where I put a line. So yes, this is a function. So sometimes to know what a function is can help solve these problems. Let's talk about one last thing about functions, and then we'll stop the video. Looking for a specific problem in our book. You don't need a graphing calculator because a lot of the problems are going to be just like they were there. I'm trying to find it where it is. So This is for my 122 college algebra students. Getting into a little more challenging problem here to do an example of. I wanted to give you a page number of the book, but I am not finding it. Okay, I found what I was looking for now. Page 88 in the book, if you want to just kind of see it, but I'm going to still do it right here, right? This is in the Pearson book for 122 students. Say we have, oh, back my annotation again, sorry. Clear. All right, say we have two functions. We have f of x equals 5x minus 3. And then we have g of x equals ax squared plus x. Right? And so basically we have the same x values. And again, you don't have to have x all the time. Obviously, we could have done g of y, but I wanted to show that it can be the same as well, plus follow the book. So what if we have the function negative a squared x, right? Now, what that means for f of x, I just put that into the function. So I have 5 parentheses. Change my color just so you can see where it came from. Negative a squared x, right? Minus 3. And now I just solve it. 5 times negative a is this, negative 5a squared x minus 3. So I'll give myself a little more room. F of negative a squared x equals negative 5a squared, that's just supposed to be a 2, x minus 3. Now, if we do the same thing for g of negative a squared x, well, that equals, remember, this is going where just the x is. So a, parentheses, change the color so we can see where the numbers came from again, negative a squared x, close parentheses, all of that squared, plus, I'm going to put in parentheses just so we can see it again, x, which means I get a negative a squared x. So remember our rules of exponents. When I'm on the outside, that goes to everything inside. So then this equals a, parentheses, negative a to the 4th, because 2 times 2 is 4, x squared. And now I'm going to get rid of these parentheses and just do minus a squared x. And now distribute my a through from the outside to get rid of these parentheses, the distributive property. Because again, that's just a single term. I get negative a to the 5th. Remember, that has a 1 on it, so 1 plus 4 is 5. Times x squared minus a squared x. So, as it equals, so this is what g to the negative a squared x is. And then lastly, our last example is what if we have a function in a function, right? So we'll say I have f of, I'll put it in brackets to make it a little bit neater. Erase. So we have a function inside of a function, right? So if I put this in words, this just means the function of the function x. The way you see it's a function inside of a function, right? So functions get pretty tricky here. So say we know f of x equals 2x squared. And again, this is number 51 in your book if you want to go look at it. So I just put a function inside of a function. So start my function of x, again, is 2 parentheses squared. That's for this guy, for the outer function. Now for the inner function, I just put what he equals to. So I put in 2x squared. And now I just do all the math, right? 2 distribute through, so 2, parentheses, 2 squared is 4. That's the squared. X squared to the squared, again, is x to the 4th. And then 2 times 4 is 8, so the answer is 8x to the 4th. Function inside of a function. So I think this is a lot. Functions seem to be tricky. So a quick review here. Let me get one of my drawings. What we covered today. We talked about what a function is. So relationship between two variables where one's independent and one is dependent. Independent is what goes in, which we always also call our domain. Our function does some processing. A dependent variable comes out, which we also call our range. There must be only one output for every input. You can't have one input and two outputs. That was an example of, so domain is all possible values of what goes in. Range is all possible values of what comes out. All right, and then we did some domain problems. When we know something is inside the function, we just substitute it in and solve for it. All right, and then we did the function of x. So, hope everyone enjoyed the video. Have a good day.